Yeah.
Can you repeat the exercise?
Yeah, 3 and 13. So example 2, here, and I'm going to underline this again, we're going to do the same thing that we did last time. This time, they gave it to us in the function notation. They said, sketch the graph of y equals negative g of x. That negative is outside the function. Outside affects things vertically. So when I see that, my brain tells me vertical reflection. That would reflect things over the x-axis. And if I name my x-axis, its actual equation is y equals 0. And this will multiply your y coordinates by a negative 1. So if I wanted to do this graphically, looking at key points, these points, maxes and mins, seem like they would be important. If I look at those points, I have the point 1, 6. And if I reflect that over the x-axis, I would have 1, negative 6. This point at 3, 2 would reflect the 3, negative 2. If you had to label these points, can you see yourself making a small mistake and calling it 3, 1? So we have to be careful. Like this scale on the y, they're going by 2s. It's actually frustrating when they do that, because you probably would have just gone over 3 up 1 and written 3, 1. And then, again, pre-calculus is about paying attention to details. That would be like, sorry, you weren't paying attention to details, half a mark deduction. So just be careful with that. I found that the textbook sometimes plays around with the scale. So it's just another thing to double check if you're labeling points. Now those are 2 key points. Sometimes that's not enough to see what's happening in your graph. We need to reflect this over the x-axis. Sometimes points that are nice to also include are x-intercepts and y-intercepts. So I'm going to just label, I have an x-intercept there, a y-intercept there, and an x-intercept there. The y-intercept, if I reflect that down, that's no problem. That would be right there. But the interesting thing is something happens special at the x-intercept. Can you see at your x-intercept, your y-coordinate would be 0. And then if you multiply that 0 by a negative 1, it's going to stay exactly the same. So when I go to graph this, put arrowheads on the end so I don't lose that E9 error. That point there should be the only place that they intersect.
Would we have to, since the original doesn't have any arrowheads?
On the textbook, whenever it ends at the edge of the graph, they assume it keeps on going. So yes, you would have to. On your quizzes and tests, I actually go in, if I take a graph from the textbook, I add the arrowheads, so I'm not hypocritical when you're doing your quiz or test. Because that's not really fair. Oh, I don't have to add arrowheads, but I can take off half mark for you. But yeah, the textbook, if the textbook ever ends at the edge of the graph, because they've used a graphing program that would continue on if they extended their graph, but wherever they cut it off as an image, it cuts off the graph as well. That assumes that it keeps on going. Again, it asks us for the domain and the range. Since this one goes up and down forever, it would also go forever to the left and forever to the right. Your domain is everything. Your range is everything. Same thing for your blue graph. domain and range would be everything. Questions for this one? 4, 5, and 6, 10, and 11. So write those down and circle them